Hi folks, we're going to take a look at page 288, number 22. Now I'm going to solve this version of the equation. It looks as though different versions of this textbook have a different function. So in one version of the textbook there's no brackets here. Now I'm going to solve it this way because the answer at the back solves it as though there were brackets around the t minus 7.5. Okay, so if you solved it without the brackets, you're likely to get some different answers here. Okay, so what they want us to do is they want us to essentially determine the first two times that the rider is 20 meters above the ground. Okay, now in the end they ask us to graph the function in part B to check our answer, and they say something at the beginning. It says at t equals 0 the rider is at its lowest point. So let's just draw a quick graph right off the bat just to kind of see that all of this makes sense. Okay, so I'm not going to worry about the vertical transformations, but here I see that the period is going to be given by 2 pi over 15. Okay, so pi's cancel out, so we're just left with 2 times 15, which is 30. And we see that 7.5 is exactly 1/4 of 30. So if you think of the sine function, and a positive sine function, so, normally sine function would look like that with those vertical transformations. And here, continued on the other side, we're moving at 7.5 units to the right. So if I move this function to the right, I see that, hey, it does make sense that I'm starting at the lowest level. Okay, and we want to determine the first two times it's at 20 meters. Okay, so let's go ahead and replace h by 20 since that's what we're looking for here. Okay, so here pi over 15 t minus 7.5. Okay, so this is a linear trigonometric equation because I can just solve for the trig expression using opposite operations. So let's subtract the 12, so it gives me 8 divided by 10, so it gives me 0.8 equal to my trigonometric ratio. Okay, so that's step one of our what do we call that? Our algorithm for solving trigonometric equations is to isolate the trig ratio. Okay, so now 0.8 doesn't correspond to a special angle, so step 2 is to determine my two answers here. So I'll start by taking inverse sine of 0.8. Okay, and that gives me, so that means, now let's make sure we know what that means. It's not t equals 0.927, it's this whole input. So that means that pi over 15 times t minus 7.5 is equal to 0.927. Okay, or the other option is that pi over 15 times t minus 7.5 is equal to pi minus that number. Okay, 0.927. Okay, so let's calculate that. So pi minus my previous answer gives me 2.214. Okay, so here equal to 2.214. Okay, so now that I've used my inverse trig button and my related angle identity, okay, I can now solve for t in each of these circumstances. So t is equal to, actually I need my calculator again. So here, okay, so notice the brackets. So first I'm going to have to divide this to the other side and then add 7.5, so 0.927. So first I'll multiply by 15, divide by pi, okay, and then add to that 7.5. So my first answer is 11.93. Okay, or do the same thing with the other one here. So I'll just, we've got now 2.214 times 15 divided by pi, okay, and add 7.5, and we have 18.07. Okay, now the only thing they're looking for is the first two times that I'm at 20 meters. Okay, so this might be all I need. So I've got two answers. The one thing that you should check is that there's no answers that are smaller than 11.93. So let's remember how we generate other answers is we just add or subtract the period of our trig ratio, which in this case here is 30. And obviously if I subtract 30 from 11.93, I'll be into the negatives, which I'm not interested in. Okay, so my final answer here is going to be at time equals 11.93 seconds and 18.07 seconds. Okay. So just to recap, okay, step number 1 was to realize that I needed to replace h by 20 and then solve for my trig ratio. Step number 2 is use my inverse trig function and my related angle identity to determine my first 2 answers. And then step 3 was to solve for t. And then step 4 was to generate all the answers that I need. In this case here, these were the only 2 answers that I needed. Okay, that's it for this one.